Hi, so today I'm going to be recapping some logs. Um, so this is exponents and logs, but mainly using log rules and like solving exponential equations. So starting off, a recap of what the definition of a log is. So assume we have some function a to the x is equal to b. The log is basically asking us um, what power should a be raised to in order to get b. So the x is what power a we have to raise a to in order to get b. So how I when I see a log, I just write it like this. I take the bottom number, raise it to x, and the number in the bracket is on the other side. So a to the x is equal to b. That's basically what this equation is saying. And this is only true if a is greater than 0 and b is greater than 0. So we can't have negative numbers inside our brackets or as our base. So that's something important that you should know. And secondly, we define what the natural log of x is, or ln of x. It is the log of x where the base is e. So an interesting, or not interesting, but a property is that when you raise e to the power of ln x, you get x back. So a lot of times you have to use this in order to simplify an equation. Here are two example questions just to recap how you compute logarithms. So this question says log base 5 of 125 is equal to x. So it's asking us what power of do we have to raise 5 to get 125? So 5 to the power of 1 is 5, 5 to the power of 2 is 25, and 5 to the power of 3 is 125. So x is just 3 here. For this question, we do it the same way, asking us 3 raised to what power would give us 27. So 3 to the x is equal to 27. So x is just 3. All right, so now we move on to our laws of logarithms. So here are just how you manipulate logs and how you can, make things easier, or how you can simplify some expressions. So first of all, if you have a product of two things, say x and y, inside your bracket, you can expand this into a sum where you have log base a of x plus this log base the same log with the same base of y. So if you expand this product, you get a sum. And the same happens with dividing, but instead we make it subtraction. So if you have log base a, and in the bracket we have x divided by y, it becomes log base a x minus log base a times y. And another property we have is that if inside a bracket our variable of concern is raised to some power, and that power can be a number or it could be some function like x to the 2x squared, you can bring that outside of the log. You take it here and you bring it outside of the log and multiply the log by it. So we have, for example, here we have m times the log base a of x. Another really important thing that you should know how to do is change of base, and this is helpful when you have a lot of different logs added together with different bases. So you should standardize their bases so you can use our log laws to make your life easier. So it says that if you have some log base a of x, it is equivalent to log base b of x over log base b of a. So I think this is in the formula booklet, but you can also remember it by having this bigger number, which is kind of above the smaller number. It's on top of the fraction as well. So yeah, that's just how it works. And here's an example. We want to find the exact value of log base 8 of 32. So I don't know what 8 to the, I don't know what this is, right? So what I'm going to do is I can notice that 8 can be expressed in base 2, and it's, 8 is 2 to the 3. So really I have log base 2 to the 3 of 32. This is our base. And we can change this to base 2. And you'll see why in a bit. If we change this to base 2, we have log base 2 of 32 over log base 2 of 2 cubed. Well, 32 is actually 2 to the 5th. So we have log base 2 of 2 to the 5th over log base 2 of 2 cube. And well, what does this mean, right? It's saying 2 raised to what power gives us 2 to the 5. So clearly it's 5. And the same is for below. 2 raised to what power is 2 to the 3. So 2 raised to 3 is 2 to the 3. And that's our answer for this expression. Now we can move on to solving exponential equations. Essentially, we just have our variable in the exponent and we want to find the value of our variable. So here we want to find x. For 5 to the power of 2x is 125. Most of the times you will be able to spot that the two numbers actually have the same base. So for example, here we're able to make this a common base of 5. So on the left side we have 5 to the 2x. It doesn't need to change. And on the right side, we notice that 5 to the power of 3 is 125. So we can express it like this. And if you remember from your rules of exponents, if your base is the same, the exponents must equal each other if they are in fact bounded by equality. So we have that 2x is equal to 3. So x is simply 3 over 2. Now this question is very similar, but this time the base that we have to simplify is with our x. So we notice that 27 is 3 to the power of 3, and 9 is 3 to the power of 2. So 3 to the power of 3 to the power of x is equal to 3 to the power of 2. And using our exponent laws, we can write this as 3 to the 3x is equal to 3 to the 2. Again, this means that 3x is equal to 2, so x is 2 over 3. And that's the way to solve these basic exponential equations. Something that IB really likes to do, so they give you some weird looking quadratic, or exponential equation, and they ask you to find x. So when you look at this, you might have no idea where to start, but we can see that 4 can be written as 2 squared, so 4 to the x can be written as 2 to the 2x, so 2 to the power of 2x. So our equation becomes 2 to the power of 2x minus 3 times 2 to the power of x plus 1 plus 9 equals 0. Now there's something more we can do inside our bracket. This actually says that this is a product of 2 to the x and 2 to the 1. So inside the bracket is really 2 to the power of x times 2 plus 9. So we can multiply this 2 with 3. We get 2 to the 2x minus 6, 2 to the x plus 9 equals 0. So actually having 2 to the 2x in that form is not really that nice for us. So we in fact, or instead want to write it as 2 to the power of x squared. And remember your exponent laws, this is the same exact thing because you multiply these two. So 2 to the x squared minus 6 times 2 to the x plus 9 equals 0. So now if we take u to be 2 to the x and use just some random variable to make our equation clearer, we can see that we in fact have a pretty simple quadratic. And yeah, so this is how you spot it. You have to try to make some variable the same so you can solve the quadratic. So here we can just factorize. We have u plus u minus 3 and u minus 3 equals 0. So u is equal to 3. And recall that u is 2 to the x, so 2 to the x is equal to 3. We have to take the natural log on both sides to bring this x down. So ln of 2 to the x is equal to ln 3. Using log rules, this becomes x times ln 2 is ln 3. So dividing both sides by ln 2, we get that x is equal to ln 3 over ln 2. So that's how you solve this kind of problems where they have a hidden quadratic. You can put this into your calculator, but in my opinion, this is a nicer form. And so now that we're done with the recap, I have some, I feel like, slightly more difficult questions that we can do for practice. So you can feel free to take your time to pause the video and do them first before watching the video for solutions. And yeah, I'll give you some time to do that. All right, so our first question, it says that we have to solve e to the power of x minus 3 plus 2 is equal to e to the power of x plus 3. So my thought here is that we have a common term of e to the x and e to the x here. So I want to try to isolate that. So I can say that this is equivalent to e to the x times e to the negative 3 plus 2 is equal to e to the x times e to the 3. So we can move our e to the x terms together. So we have 2 is equal to e to the x times e cubed minus e to the x times e to the negative 3. So now we can take out this common factor of e to the x, and we can solve for e to the x now. So e to the x is simply 2 divided by e cubed minus e to the negative 3. And if we take the natural logarithm, I'll bring it over here, ln of e to the x is equal to ln of 2 e cubed minus e to the negative 3. Remember that ln of e to the x is just x because, you know, ln is log base e. And then this right side, we can write this as subtraction using our log rule. So we have ln 2 minus ln e cubed minus e to the negative 3. This is in a bracket for clarity. And we can simplify this denominator. Well, e cubed minus e to the negative 3 is really e cubed minus 1 over e cubed, which is e to the 6 over e cubed minus 1 over e cubed, which is e to the 6 minus 1 over e cubed. So x is equal to ln 2 minus ln e to the 6 minus 1 over e cubed. And then we can write this using subtraction again. Minus this in a bracket, ln e cubed. I'm scooching into the next question, but that's fine. So ln 2 minus ln e sixth minus 1 plus ln e to the 3. This final term is just 3. So we have ln 2 minus ln e to the 6 minus 1 plus 3. And well, that is our answer for this question. Yep. So it's a bit tedious, but you just have to follow all the steps and you should be able to get a nice answer at the end. So for our next question, it says that x raised to the power of log base 2 of x is equal to 16. So what can we do here? Well, I think I want to take the log base 2 of both sides, because we have a log base 2 in the power, and if we bring it down as another log base 2, we can have a product, which could help us. So if I take the log base 2 of the left side and log base 2 of the other side, the right side just becomes 2 to the 4 is 16, so this is 4. The left side becomes log 2x multiplied by log 2x. That's because we can bring this power of x down and multiply it by our log base 2 of x. So this turns into log base 2 of x squared is equal to 4. Well, this is simple enough. Log base 2 of x is just plus or minus 2 because 4 is a perfect square. It works nice for us. So we have two situations. Log base 2 of x is 2, and log base 2 of x is negative 2. So, well, what power do we raise 2 to in order to get 2? Or sorry. Well, let's write this in exponential form. So 2 squared equals x, and x is clearly 4. And over here, 2 to the negative 2 is equal to x. This is really 1 over 2 squared is equal to x, so x is equal to 1/4. And these are our two solutions for this question. The next question, remember to pause. I kind of forgot, but you should remember. This question says that log base 2 of 2 to the power of x minus 1 is equal to 2. Well, what can we do here? We can exponentiate the base 2. So if we take 2 to the power of log base 2 of 2x minus 1 is equal to 2 to the power of 2. Well, we notice that, this log is asking us 2 to the power of what gives us 2 to the x minus 1. So if we take 2 and raise it to that power, we just get 2 to the x minus 1 is equal to 2 squared, which is equal to 4. Well, now this, oh, well, this is just great. And 2 to the x is equal to 5, and x is equal to log base 2 of 5. And this is how I'm just going to leave my final answer, because in paper 1 you don't have the calculator and you don't need to write it out. So for this next question, it says that ln of e to the x plus 2 times e to the 2x is equal to 0. So this uses a really similar approach to the last question, where we just raise everything to the power of well, no, we raise e to the power of the left and right side. So on the left side, we have e to the ln of our expression, and on the right side, we have e to the 0. And remember that any number or variable raised to the power of 0 just gives us 1. And on the left side, remember e to the ln of anything just gives us that inside variable. So we just have e to the x plus 2 times e to the 2x is equal to 1. Well, what do we have here? We can call u e to the x, which gives us u plus 2u squared is equal to 1. 2u squared plus u minus 1 is equal to 0. And I'm just going to tell you, you have to use a quadratic formula for this. So u is negative b, which is 1, plus minus square root of b squared, 1 squared, minus 4 times AC, which is minus 4AC. It's just 8. Because we have a negative 1, so the two negatives become positive, over 4, because it's 2a, and this simplifies to negative 1 plus minus 3 over 4. And well, we actually have to do some casework to see whether all of our solutions work. So our first candidate is negative 1 plus 3 over 4 equals half. Well, this works. But our other solution will yield a negative number, and u is e to the x, and e to the x can't possibly give us a negative number, so we have to reject the solution, and our only answer is e to the x is half. So x is ln of half, which is negative ln of 2 if you want to write it more. And now we just have 2 questions left if you want more practice. And this is asking us to find the inverse of two functions. Well, the first function, we have y is equal to e to the x. Well, we switch our variables, so we have x is equal to e to the y, because an inverse is a reflection across y equals x. So this is how this comes. And what do we do to get that y down? We take the ln of both sides. So ln x is equal to ln e to the y. Ln x is equal to y ln e. And what is ln e? Ln e is just 1. So we have y is equal to ln x, and that is the inverse function of e to the x. And you can check this. In fact, if this is e to the x, this is ln x. So, you can tell from the graph, or you can use your calculator. And now the inverse of g of x, well, g of x is ln of 1 plus 2x. So y equals ln of 1 plus 2x. X equals ln of 1 plus 2y. And then we want to get the y out, so we put e to the x is equal to e to the ln 1 plus 2y. So e to the x is equal to 1 plus 2y. 2y is equal to e to the x minus 1. Y is equal to e to the x minus 1 over 2. And yeah, that is nice. And finally, I'm not going to do the other questions for now. Or, you know what, I'll do it, yeah. This is a pretty easy question. It just wants us to simplify this expression. Everything is in the same log base, so it's pretty straightforward. The first two terms, they're adding together. So if you remember our log rules, that just means inside the bracket they are being multiplied. And then minus log base 3 of 4. So that means you have to divide everything by 4. And you just have to compute this. This is log base 3. 16 times 2. 16 divided by 2, this leaves 8. It's 8x over 4, which is log base 3 of 2x. And yeah, that's that question. And now I think this is a little bit challenging, but it's manageable. And well, it's a oh, I did the question here, but just ignore that. Well, it says that we have simultaneous equations, and we have 2 to the power of x squared is equal to 4y, and log base x of y is 3 over 2. Well, that's a little weird, but we try to do what we can, and we can simplify this equation first. So we have log, no, 2 to the power of x squared is equal to 2 squared, or 2 to the power of 2y, because 4 is 2 to the power of y. So we have x squared equals 2y because our base is the same, and y is equal to x squared over 2. And now we can substitute this into our other equation to solve the set of simultaneous equations. If this, if log base x of y is 3 over 2, then x to the power of 3 over 2 is equal to y. And remember that y is equal to x squared over 2, so x squared over 2 is equal to x to the power of 3 over 2. Well, we multiplied both sides by 2. X to the power of x squared is x to the power of 2 times of x to the power of 3 over 2. So um, we can multiply, no, we can divide by x to the power of 3 over 2, which gives us 2 is equal, this is here, x squared divided by x to 3 over 2, which is x 2 minus equals x to the half. So x to the half is equal to 2. 1 square root of x is 2, so x must be 4. And yeah, now we have to solve for y. Y is x squared over 2. 4 squared over 2, it's 8. So x equals to 4 and y equals to 8. And that's it for the video, and I hope you guys this helped for your tests, or you got some new information out of that.